All right, as usual, gonna give everybody some time to get in and set up.
Doesn't already work. Yeah. I told Ma, because I fucked up last night. I didn't realize the grocery store closed that damn early. It went up to like 8:10. Everything goes on early. That shit dumb as hell, man. That shit heavy.
All right. So, hello everybody. Hope we're doing all right after this weekend. So we're going to finish up the last little bit we have for this section, and we're also going to talk about the tests and how they're going to be working in this class. All right, so so up to now we've been doing what is called analytical trigonometry, basically taking trig equations and from a few basic definitions, we kind of expand upon those and see what all we can make from some very basic relationships, whether they be the, sorry, I'm getting my studio lighting fixed, whether they be for maybe that'll be okay. Sorry, we've been taking basic equations, basic relationships due to, or from like Pythagorean theorem, what we know about right triangles, the definitions of sines and cosines, that kind of thing. And we take these and then we kind of stick them all together and figure out what else can we tell from this? What can we do with this information? So we're going to look at some stuff that's kind of near and dear to my heart. One piece of which is something called projectile motion. Just as a bit of a curiosity, does anybody know what constitutes a projectile? And specifically, what constitutes projectile motion? What is a projectile? Can anyone give me an example of one?
An object being thrown in a certain direction at a certain angle.
Okay. Little over scientific, but a ball that has been thrown in the air. Great example of a projectile. An arrow that has been fired. This is one distinction that people don't really think about, but a projectile is those things that we mentioned. It is not something like a rocket or something that can, or like a glider even. It's not, the idea of a projectile is it's something that you throw it, you give it some initial, launch, and then it's just falling. It's not doing anything to change how it falls. Like a glider can, turn or steer. A rocket is boosting itself, so it's still pushing itself. Projectile, very good, is something that is thrown or initially launched, and then it just goes. So projectile motion, and this is ignoring air resistance. The range of a projectile fired at an angle theta with some initial velocity. And if you end up in my physics class, about half of physics 1 is going to be this kind of stuff. But for our purposes, if you launch a projectile, some initial velocity at some angle theta, then its range, or how far it travels before it hits the ground again, is given by this equation. I'm going to write it a little bit differently. All right. So the range, keep our variables same, R depends on how fast you throw it and the angle at which you throw it. Okay? Makes kind of sense to most people. So we want to change this equation to something a little bit more manageable. What specifically, what we want to change it into a single function, not two. So this has sine and cosine. So we want to change it into something that has a single function attributed to it. So what could we?
Dr. Dean.
Yes.
Caleb said, can you sign him in, please?
Can I sign him in?
Mm-hmm. Or let him in.
He's not trying to get in? I don't understand.
He said that he can't get in.
Well, he's not in the waiting room.
Okay.
Um, all right. So, okay. So we need to change this, or we want to change this in something that's a little bit more manageable. So what is a relationship that we've talked about that we could use for this? And I'll show you guys what it looks like while you're sitting there thinking about that. Yeah. So if you type in list of trigonometric identities, go to Wikipedia. This is a great source for a lot of stuff. One thing is it's got the unit circle in all its glory, right there, front and center. And then it also has all of this stuff, some common conversion stuff that you might find helpful, definitions of the basic trig functions, inverse definitions, Pythagorean identities, all of these other identities. I mean, it just goes on and on and on with every possible relationship that. So these are the angle sum and difference formulas. We have double angle formulas, triple, half. Nice little subset over here in all different kinds of terms. So we did not cover a lot of these crazier ones. They're just common enough to other disciplines that somebody felt the need to write them down. But this is a great resource for looking up any of this stuff. So I highly suggest for this course and for when you get into calculus a little bit more, this will be a very, very helpful resource for you. Okay. So with that, where is my button? There it is. All right, so what can anybody give me an identity we might want to use for this one?
Tangent.
Not tangent, because that would, tangent is sine over cosine. So if we had sine divided by cosine, then yeah, we could do that. But if we add tangent in, it's going to end up getting more involved. So a good rule of thumb for this kind of stuff is find an equation that has sine theta and cosine theta multiplied together on one side, and then something by itself on the other side. So what equations in our list have sine and cosine together?
Do you mean the Pythagorean theorem?
No, that's sine squared plus cosine squared. I want something that has sine of something times cosine of something. So one of the ones that has these two together is, we'll get rid of this. So don't really need it. So sine of A plus B equals sine A cosine B plus sine B cosine A. So this has sine of something and cosine of something together. So we could use this one.
Or you can use cosine A plus B, the other one.
You can't use the cosine one because
Okay.
cosine A plus B is cos A cos B and minus sine A sine B. So this one has cosines together. Okay. But let's look at this one. So sine of something and cosine of something. Well, what is A in this case? What is A in the black equation? Sine of A, cosine of B. What is A? The equation says sine of what?
Theta.
Theta. What does B equal? Theta.
Theta.
So sine theta cosine theta plus sine theta cosine theta. Well, what does that equal?
Wouldn't that be 2 cosine theta? No, 2 sine theta cosine theta.
Yeah. So there's one of these things and a second one. So it's just 2 times that. Okay? But that's supposed to equal sine of A plus B. What does A equal? What does A equal? Come on, y'all.
Theta.
Theta?
Theta. What does B equal?
Theta.
Theta. What is theta plus theta?
2 theta.
2 theta. Gosh, Destiny, let me answer.
I'm sorry, man. Gosh.
Okay. So this is the one that I was kind of hoping to get from the start, but we re-derived it. This is the double angle formula, where sine of 2 theta equals 2 sine theta cosine theta. But again, relationships are supposed to work both ways. So that means that we could take this thing and make it into this, or we can take this thing and make it into that. So let's adjust it a little bit and bring that 2 over here. So if we have sine of theta, cosine of theta, we can take that out and replace it with this thing. We do that up here, we get R equals V naught squared over 16. We had sine theta, cosine theta, but we're replacing it with this thing. And is there a way that we can simplify this a little bit? Like combine it into one fraction, maybe?
Would it just be sine theta?
No. No, you can't go into the function. You can't like go in and take stuff out. If it's in the function, it's kind of protected, and you would have to do some other crazy stuff. But that's the whole point of these rules that we're learning, is it allows you to mess with stuff that's in the function, because you can't just divide a 2 out. You have to go through this process. But something over 16 times something over 2 just becomes, we can take this 2 and put it with that 16, which gives us 32. So this is the projection model with a theta of, or with a single function instead of a product of 2 functions. So in the example that we do, we also want to look at part B. So at what angle must the player kick a football, which is a type of projectile object, if you kick a football? If you kick with an initial velocity of 80 feet per second at an angle of 45 degrees, will it result in a distance of 200 feet? So that's what we're going to check. So let's take the two numbers, 80 feet per second is our initial velocity. And our range is 200. Let's see if we can figure out what angle we would have to kick at for that to be the case. So we're solving this thing for theta. Okay. So let's not plug stuff in yet. What should you do to solve this for theta? How do we generally solve for stuff? Called the isolation method. We want to isolate the thing that we want. So
Are we gonna subtract the fraction to get sine 2 theta by itself?
we're not going to subtract the fraction. Because it's being multiplied. So we need to get sine of 2 theta by itself. So how do we do that? How do you move this thing to the other side?
Divide, right?
Divide it. Yay. So if you divide this over here, you'll get r over v naught squared over 32. But there's a different way to write that. We can move the 32 somewhere else. Where can we put it? Okay. Now we plug stuff in. So let's simplify this thing. 80 squared is 80 times 80. Eighty times 80 is 8 times, so I'm gonna do it like this. 10 times 10 times 8 times 8. So what is 200 divided by 10 times 10?
2.
2. So that equals 64 over 8 times 8. What is 64 divided by 8 times 8?
1.
1.
1. So, sine of 2 theta equals 1. When does the sine of something equal 1? I said sine of x equals
Yeah.
1. What does x equal?
0.
Pi.
Does x equal 1?
Theta?
No.
Is it pi over 2?
Pi over 2, or 90 degrees. So, sine of 2 theta equals 1. What does that mean?
Does it mean sine of just theta equals 1/2?
No. We said that sine of something, when sine of something equals 1, that something equals 90 degrees. Well, the something is 2 theta. So that means that 2 theta equals 90 degrees. So what does theta equal?
45.
45.
There you go. Okay. So this is a, yeah, good example of using these analytical equations to solve an actual problem. Because we're running out of time, I'm going to go over this kind of quickly, but so this is the document for online tests. Y'all's test main point for right now will open Tuesday morning.
So I go in my mama room. So I go in my mama room and I hear fucking talking. This is now. Yes, a nigga.
J
talking.
Love.
I'm like,
J Love.
Jello.
what? And I realized that my dumb ass still in class.
So, yeah. So,
Jello.
Oh my god.
so the tests will be open tomorrow morning, and they will close Friday at 5 p.m. This document is going to be uploaded to your let's say it's going to be uploaded to your MyAllen e-learning
Wow.
Math 114, and it's going to be under resources, which is where I'm going to be putting a lot of documentation stuff. So it'll be over here, and it'll say online tests. But so if we run out of time, just click over there and you can look at it. Your tests are going to pop up, and they will look like two normal assignments. They will say test, try 1, or test 3, try 1, test 3, try 2. So your test will be timed. You'll have 75 minutes to complete each attempt. Do not open them unless you are ready to take the attempt, because the timer will start as soon as you open the assignment. You can open it at any time during the time that they're open, so basically from tomorrow morning until Friday evening. But don't open it unless you're ready to take it, because otherwise that timer will start and it'll run out. It will look a lot like your normal homeworks other than that. But you will have 2 submissions per question instead of just 1. Or on homeworks, I think you usually have like 10 or 7 or something. I can't remember. But you'll have 2 per question on these tests. With that, also save your work. There's a button next to the submit button on a timed thing that will say save. So if you have an idea, but you're not exactly sure and you don't want to waste an attempt, but you need to move on or something, you can enter a number in and click save, and it won't submit that as your answer. But if the time runs out, then it will submit that as your answer. So make good use of that. I highly suggest that you use Chrome or Firefox. I have seen some issues with WebAssign and Safari, and I've seen a ton of issues with Internet Explorer, also known as Microsoft Edge. Chrome you can download on any device, whether it's a computer, phone, tablet. It works on Mac products. So anybody can get Chrome. I highly suggest it if you're not using it already. Yeah, so you will see those pop up, and we're probably going to get cut off soon. So check this document, and I will be in the office for questions after this. After this class. So if you do have anything, email me or get on there and ask me. Otherwise, thank you guys.